Okay, so today in this class we'll discuss this question 52, 53, 4 and 5. Okay, class 10, chapter 10, science, light. So this question here, 52, we'll discuss first. There, open your tuition note on page 105 and take your tuition copy and write along with me. What we'll discuss an important concept today is lateral displacement. Just listen carefully, it's quite easy. What is lateral displacement under refraction? Okay, so here let us take a glass slab, means a thick piece of rectangular glass slab. So you draw that on your practice copy. Rectangular glass slab you take, and draw it properly, the rectangular glass slab. So this is the rectangular glass slab. Okay, so compare this piece of glass like this, a thick piece of glass like this rectangular piece, so thick, transparent glass piece, colored as. So this, when you compare it above its surface, is nothing but the air. So this will be rarer, we know that, and this will be denser. Compared to air, glass will be denser. And then below it is again air, and that will be rarer again compared to glass. Air is rarer than the glass. We're taking like that. Then you pass a light ray. We've already done refraction, so this should not be hard. So let's just pass a light ray obliquely, means not making 90 degrees to the surface of the rectangle. If you pass the light ray like this, this is 90 degrees. So don't pass the incident ray like that. Pass it obliquely like this. So this is called the incident ray. The first ray that is passed from air, which is the rarer medium, into the, this one is the incident ray. So here, as you pass this ray, so this is your incident ray. You can write it if you want. Now, where it's touched the surface of the glass, boundary between air and glass is called the interface. That point where incident rays strike the interface is called point of incidence. So exactly at the point of incidence, if we draw an imaginary line, let's say this is AB, the ray is AB, also PQ. Let's just take the same as the notation of PQ. Let us say this is PQ. Then if you take here PQ, 90 degree, okay, PQ, then this line which is drawn 90 degree to the interface at the point of incidence is called the normal. So N, Q, N dash, let us say. We took this one. So here, now as it enters from rarer to denser, we know that the ray bend towards the normal. If it enters from denser to rarer, it bend away from normal. But we know by now that a ray entering from rarer medium like air into a denser medium like glass will bend towards the normal. So away means like this, it will bend. But towards means towards this line normal. So it will bend like this. And it will come here, right? So it will come like that. So this ray here is called the refracted ray. So if we want, we can write here. Just draw along with me, you'll understand it very easily. Refracted ray. This is incident ray, refracted ray now. Now the angle between this incident ray and the normal here is called angle of incidence, let us say. First one, I1. And this is called the angle of refraction, let us say. Small r1. Now as it enters from this glass, it's going to come out here, again, below the glass. But before that, let us draw here a normal at this point. So here, if we draw a normal, means a line which is 90 degree. So PQ, and this one, let us say R. This refracted ray is R. M, R, M dash, let us say. M, R, M dash. Then this here, let us take it as I2, this angle between the refracted ray, this one, I2. I2. Then it will bend away, and be careful here, it will be parallel to this, okay? So make sure your scale is parallel to this one. Now as it come from this now denser to rarer, opposite will happen. Here from rarer to denser, so bending towards normal. But now the ray is entering from denser to rarer, so it will bend away from the normal. How much away? You just assess it like this. Always you'll find out that this ray will come out parallel to this line, okay? So you let your scale be parallel to this first incident ray, and it will come out bending away from the normal, because it is entering now from denser to rarer. So the final ray is this one. This ray is called the, most textbook call it as emergent ray. Emergent ray, the final ray. Now as you produce this one here, the first incident ray, you produce it by imagining the same straight line produced like this. We will always find that the incident ray produced or the incident ray is parallel to the emergent ray, the final ray that comes out. And between those two rays, incident ray produced and emergent ray, you draw a line perpendicular to emergent ray or incident ray, perpendicular. Then you take your scale and measure this distance here. Let us say this is the distance between the incident ray produced and the final emergent ray. Perpendicular distance between them is this one, let us say. And this one is, okay, PQR. And the last ray comes out here, S. PQRS. Then here, okay, so here let us say this is Y. This point is Y and this point is Z. So this distance YZ, whatever you get, let us say 10 centimeter you got by measuring, then that distance 10 centimeter is called lateral displacement, the perpendicular distance between the incident ray produced and the emergent ray when you pass a ray from the top of a glass slab and cause it to come out of ear finally. That perpendicular distance is called lateral displacement. Quite easy, right? Let us read there. Go to page 105 of your tuition note. Let me read that thing. In the figure, the incident ray PQ is incident obliquely on AB. That is ear glass interface on AB. So here this surface on AB. Let's say AB. There is ear glass. It's missing there on your tuition note also. So just write there AB, just like I did just now. Then QR is the refracted ray that is there, and RS is the emergent ray. RS is the emergent ray. Is incident obliquely on AB. QR is refracted ray. RS is emergent ray. This is a case of refraction through rectangular glass slab. Produce PQ to X. So this PQ is produced to X. Write this one on your note. Okay, X. It is noticed that the incident ray produces parallel to emergent ray. Like we got here, this emergent ray is parallel to incident ray produced. They are parallel always. The perpendicular distance YZ, which is also called sideways shift. So this is also called sideways shift, this distance. Sideways shift between the incident ray produced and the emergent ray is called lateral displacement. So I hope you have understood. The next question is 53, 4, 5. We just have to read through. Look into your tuition note, page 106. When a light ray is incident normally to the interface, you can write down question number on your tuition copy, practice copy, 53. When an incident ray is normal, when a light ray is incident normally to the interface between ear and glass of a rectangular glass slab, no refraction will take place, or the ray passes through the glass without bending, and the emergent ray also comes out without refracting. Yes or no? Yes, tick there yes. And then you can write on your tuition note a glass slab like this. So this is your glass slab, a rectangular glass slab. Then if you pass it an incident ray like this, normally means 90 degree. Then what happens is bending will not happen. It will just come out. Refracted ray doesn't bend, emergent ray. Well, all of them will be on the same straight line and there will be no bending. Yes, okay. So that's why we have to pass it not like this but obliquely. Then only refraction will take place and the emergent ray will come out bending. Okay, the refracted ray will bend, refracted ray will bend, then the emergent ray will bend. No bending will take place when you pass an incident ray 90 degrees to the rectangular glass slab. Yes, okay, 54. So go to 54 and scribble these things on your question note where you do as practice. That one will really help you during exam. In question number 51 just now, refraction through glass slab ABCD. 51 ABCD. So complete that one. Okay, first question number 52. Rectangular. The light ray bends away from normal at a glass. Question number 50. 1 or 2 you can write there. In question number 54 you write in question 51 like this on your note is there, or 52 also same. Refraction 51 was an activity I didn't do, so just read through it yourself, you'll understand it. Through a glass slab, the light ray bends away from the normal at the ear glass interface as it enters from rarer to denser medium. These things we know now, right? It will bend away if it enter from it will bend away from the normal at the ear glass interface. Bend away from the normal at the ear glass interface, enters from rarer to denser medium. So angle of incidence is greater than the angle. This is mistake, you please correct it. Okay, the light ray bends the light ray bends away from normal as it enters from ear to glass interface, as it enters from rarer to denser. So it will not bend away, cut the word away and write towards, bend towards, okay, towards normal. So the angle of incidence is greater than angle of refraction, means I1 greater than I2. Yes, tick there, yes. The next paragraph, likewise the light ray bends towards the normal at the glass and ear interface as it enters from denser to rarer. Towards, that one you cut, towards, and right there, away. Second paragraph should be away. The normal at the ear glass interface as it enters from denser to rarer medium. So the angle of incidence is smaller than the angle of refraction. I2 smaller than R2, yes, right? So the correction. Then 55, the two laws of refraction. So in order to understand the two laws of refraction, just write on your tuition copy question number 55, two laws of refraction. These two are the two famous laws of refraction. So let us take here a case of refraction. So you can just take here glass again, or even water also you can take, draw it. And we will try to understand this. So this is the rectangular glass slab. Above it is the ear. Let's pass a light ray obliquely. Here, this is called the, if you do that, the first ray is called the incident ray. So this is the incident ray. This point where it strikes is called the point of incidence. Let us there draw normal. This is the normal at that point of incidence, means make it 90 degrees. So they enter from air which is rarer compared to glass, it will bend towards the normal. So it will bend towards the normal. So this is called the refracted ray. This one which is bent towards the normal is the refracted ray. Draw this along with me, okay? Refracted ray. So the angle between the incident ray and the normal here is called the angle of incidence. Here is called the angle of refraction between the refracted ray and the normal, small r. Now we'll discuss the two laws. The first law says like this: this incident ray, when refraction takes place like this incident ray, the refracted ray, and this normal, all these three lines will be on the same plane, plane. What does that mean? All these three lines will be on the same flat surface like this. If this is the incident ray, this is the refracted ray bending one, and if this one here. This is the normal. The scale represents the normal, like this, normal. So this is the incident ray, as you can imagine, incident ray. Then as it enters the glass, it will bend towards the normal, so like this. I think the picture is like this. So this is the normal, this is the incident ray, this is the refracted ray pencil, and this scale is the normal. Then all these three lines will be on the same flat surface. Means if you look from side, first one will cover the other two, and we will not see the other two lines. What it means is that refracted ray will come out of the flat surface, not like that. Normal will be out of the flat surface, but all of them will be on the same flat sheet of paper. Means plane is a flat sheet of paper. Okay, so that is the first law. Second law is like this. Number 2, second law is also called Snell's law. This is very important, okay? Snell's law, or second law of motion, or second law of refraction. Now here, you take this one here, sine I. Sine of the angle I means sine of angle of incidence divided by sine of the trigonometric ratio R. This will be a constant always. It will be a constant for a given pair of media. For air and glass of the same quality, it will be a constant. Means this, it means this one, okay? Suppose this is I, then let us say you changed it, you increased it, then this is angle is I2, then this bending will also be the second one, number 2 ray, number 2. Then this here will be the R2. Then you divide, first case is small one here, you did pass less obliquely, and then you got angle I, and this R, you got constant. Means let us say you got a value 24. Just let us use a number. This is not accurate, but it will help you understand. Then sine, now here I was lesser, R was this one. Now you increase that more obliquely, then the angle of incidence more than the first one, I2 increase, so I2 by sine. Then the refraction, the corresponding is this one here, R2, so the angle of refraction also increase. So it has changed. This I1, I2 and R2 are different from this one. But even if you have changed it, it will be equal to the same value, 24. That's the meaning of, it will not change, constant. Okay, so for a given pair of media, even if you keep on changing the angle of incidence, the angle of refraction will change in such a way that when you divide sine I by sine R, the value is not going to change for the same set of media, air and glass of the same quality. Of course, if you replace air and another substance, water, the value will change, but for a given pair of media, sine I by sine R is always a constant. Means even if you change the angle of incidence, the angle of refraction will change in such a way that when you divide sine I by sine R, the value will come out constant. Means same in all the cases. That's called Snell's law. And this ratio here, sine I by sine R, sine of angle of incidence by sine angle of refraction, is also called refractive index. So let us read the answers one before we end this class. Last question. Okay, question 55, page 106. The incident ray, first law, refracted ray and the normal to the interface of the two transparent media at a point of incidence. All these three lie in the same plane, PLANE. Second one, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color, for the same light, and for a given pair of media like air and glass. Then the value will not change. This is also called Snell's law. Sine I by sine R is equal to a constant, never changes. It's also called Snell's law because Snell is the scientist who discovered this, I think. Where I is angle of incidence, R is angle of refraction. This constant value, which is sine I by sine R, sine of angle of incidence by sine of angle of refraction, is also called refractive index of the second medium with respect to the first. That means sine I by sine R is the refractive index of glass, okay? Because the rays entering from air to glass means first is air, second is glass. So when you do that, sine I by sine R will be the refractive index for second medium, which is glass, with respect to air. Okay, so this is the last question for this class. We'll continue in the next class. Okay.